Okay, welcome to the chapter on Vega. So far we've seen delta and gamma. Now, Vega is the Greek that responds to changes in implied volatility. So again, we are looking at the spiders, and what I'm going to do is get all the options closed out, and also I'm going to customize my layout here. Okay, so let's start with our May series again. It's got 60 days to expiry, and what we have here is Vega. So the Vega column you can see is, in fact, let me get the last price also out. So all we have is the bid-ask prices and the Vega. So this is the May option series, and you can see that if the at-the-money call and at-the-money puts will be at the strike price of 141, because the last traded price is $140.85. So the closest strike price to the money is going to be the 141 strike price. So Vega is shown here as 23 cents, and then on the call side as well it's 23 cents. And again, just like gamma, the concept of Vega works exactly the same for either calls or puts. So we don't need to look at both of them. If you understand it conceptually from one of those options, the same principles carry over to the other one as well. So to keep things simple, we'll just look at call options, and you can see that the Vega here is 23 cents. So what this means is for every 1% change in implied volatility, this option is going to move by 23 cents. So option prices move because of three different variables. One is the price movement of the underlying, two is the implied volatility, and three is the time to expiry. So those are the three variables, and Vega looks at implied volatility. So actually what would be helpful here is to look at implied volatility also as a column. So I'm going to add implied volatility to the column, and now we can see the implied volatility column on both the call as well as the put side. The 141 call, which is at the money, has an implied volatility of 15.44%. So it's about 15.5%. And its Vega is 23 cents. So let's say the implied volatility goes up from 15.44 to 16.44, then the price of this option is going to increase by 23 cents. I think that should be clear. If the price here is about $3.30, it's going to increase by 23 cents. So even if the price of the underlying does not change and only the volatility of this option changes by 1%, then this option is going to increase in value. If the volatility increases by 1%, then the price of the option will increase by 23 cents. If the volatility goes down by 1%, the price of this option will go down by 23 cents. So the price and the volatility are correlated with each other, are directly correlated. So if there's an increase in volatility, the price of the option will also increase, and if there's a decrease in volatility, the price of the option will reduce. So that's the basic principle of how Vega works, and it tells you how much the price of the option will move for a 1% increase in implied volatility at the option level. So the question is, why is Vega directly correlated? Meaning, why does the option prices increase with an increase in volatility, and why do they decrease with a decrease in volatility? You have to go back to our real world example where we looked at the real estate example in California, and we said that if the volatility of that piece of real estate was plus or minus 20%, then the option prices will also increase because of the increased volatility in that asset. So volatility has a direct impact on our option prices. So the more the volatility, the more the option prices will be. And the reason for that is if volatility is high, then those option prices can jump around. So again, it comes back to this ability to jump around or move around. And so this is very important. This ability to jump around is a constant principle of options. And regardless of whatever Greek you're looking at, whatever option series you're looking at, and whatever expiry series you're looking at, you have to view options in the context of its ability to jump around. The more it has the ability to jump around, the higher the option price is. So in that sense, it relates directly to the concept of volatility. Now, let's notice one more thing again here. You see that the Vega for the at the money option is 23 cents. And just like Gamma, as you go in the money, you can see that the Vega is reducing. And just like Gamma, as you go out of the money, you can see the Vega reducing as well. And again, this should make intuitive sense because the at the money options have the maximum ability to jump around, and there's maximum uncertainty associated with those at the money options, and therefore at the money options will have the highest Vega. If you noticed in Gamma, as we came towards expiry, Gamma actually started increasing, and Gamma became a much more forceful factor as you approached expiry. In Vega, it's just the opposite. In Vega, as you approach expiry, your options are going to have less Vega. And that's because there is less time in these options to jump around. So again, its ability to jump around in 32 days is limited when you compare it to the May options, which have 60 days. So the ability of the May options to jump around is obviously more because it has 60 days to do the jumping around, and the April series has only 32 days. So as you approach expiry, Vega actually has a lesser effect. So let's look at the quarterlies, and you'll see that the Vega is reduced further. The at the money options have a Vega of 10 cents. So these options are not impacted by Vega that much. And finally, if we look at the March weeklies, you'll see that the Vega is even less. It's only 6 cents in this case. So lesson number 2 is as you approach expiry, Vega reduces. That is in contrast with Gamma. In the case of Gamma, as you approached expiry, Gamma became more and more powerful, more and more strong, and the ability for it to move the delta was much more as you approached expiry. In the case of Vega, as you approach expiry, Vega reduces. And the flip side to that coin is as you go further away, Vega is going to increase. So the June options have a Vega of 28 cents. So for every 1% change in implied volatility in the June options, it's going to jump. The option prices are going to jump by 28 cents. Similarly, we can go out, let's say, to December of 2012, which has 277 days. The Vega, you can see, is 48 cents now. And so on and so forth. If you go to March 2013, you're going to see a Vega of 55 cents. So as you go out further into time, Vega is going to increase because there is much more time available for those options to jump around. And so volatility has a greater impact on option series that are further out in time. So that's takeaway number 3 about Vega. Then the fourth important point is whether you're an option buyer or whether you're an option seller. So if we look at the buyer-seller perspectives, we saw that if you're a buyer of options, you want volatility to increase. after you've bought the option, obviously. So from a buyer's perspective, you are called as a positive Vega position, because if volatility increases, then the prices of the options are going to increase, and as a buyer, that will benefit your position. Because as a buyer, remember, you've bought an option and you've paid a certain price, and so now to capture a profit, you need to sell that option, and obviously you need to sell it at a higher price. As a seller, it's the reverse. You've already sold an option and now you need to buy it back to close your position. So when you sell it at a higher price, as a seller, you want to buy it back at a lower price to capture the profit. So positive Vega is a position that will be created when you buy an option. When you buy an option, you're set to be positive Vega. And when you sell an option, you're set to be negative Vega. We'll understand this as we go into the next course, where we are actually going to be buying calls, selling calls, buying puts, and selling puts. There we're going to be looking into the concept of position Vega, and we look at all the Greeks in totality. So that's what the next course is going to be about, we're going to look at all the Greeks and see how they all work together and how we can conceptualize and visualize our option position with all 4 Greeks in mind. Finally, I want to leave this Vega chapter by telling you one thing. For any option position, you're always going to see a battle between Vega and Theta. Theta is the Greek that we are going to cover next in this course, so I'll wait to explain that issue till we get there. But in any option position, you're going to have a battle between Vega and Theta, and a well-structured position should try to find the optimal balance between these 2 Greeks. So that is as far as Vega is concerned, and as usual, if you have any questions, please send me an email, info@hackertrading.com. But in the next chapter, we're going to look at Theta, and then finally we're going to get over with this course on the Greeks, and we can get into the real live trading sessions. Thank you.